Now let's look at another way that we can organize all of the possible outcomes of an experiment. Similar to a table, a tree diagram is a visual way of organizing information. But instead of using straight rows and columns like a table, a tree diagram organizes outcomes using branching lines. Let's look at this example. You have three shirts, yellow, gray, and red, and two pairs of pants, jeans and sweatpants. How many possible outcome combinations or outfits can you make? Now remember, when we're working with this type of probability, we're considering each event to be independent. What that means is that we are randomly selecting a shirt and randomly selecting a pair of pants. Our shirt selection will not have any impact on our pant selection. So to set up our tree diagram, first we put a heading for event number one, in this case, the shirts. Then we put a heading for event number two, in this case, the pants. And finally, we put a heading where we will put our possible outcome combinations. Next, we have to list all of the different shirts that we have. As you'll recall, we have yellow, gray, and red. Now we know that each of those shirts can be paired with either jeans or sweatpants. So, under the pants heading, we list all of those different outcome possibilities for each shirt. Then we connect the shirt and pant combinations using lines. You can see how this looks a little bit like the branches of a tree, hence the name tree diagram. Finally, we move from left and right across the diagram to pair up the different shirts and pants, or the different possible outcomes. And we list all of the outcomes under the far right column. So if we choose to pair the yellow shirt with jeans, we would create a YJ outcome combination. If we pair the yellow shirt with sweatpants, we create a YS outcome combination. If we pair the gray shirt with the jeans, we get J or GJ. And if we pair the gray shirt with sweatpants, we get GS. Finally, the red shirt. We can pair it with the jeans to make an RJ combination, or we can pair the red shirt with sweatpants to make RS. Now we take all of those possible outcomes and list them in a sample space. You can imagine how some sample spaces get very large. Even just think about your own wardrobe. If you had to think about all of your possible shirt and pant combinations, how many combinations would you have? Or what if you threw in all of your choices for socks or shoes? You can see how with some experiments, the sample space can get very large. So having tools like tables and tree diagrams to organize the information can be very helpful. And of course, in very large experiments, we often use computers as tools to help us with all of this data. Please make sure to reach out if you have any questions. Thanks so much, everybody.